Hello everyone, welcome back to my channel. So in this video we'll see some more problems on Milne-Thomson method and harmonic conjugate concept. Okay, if you are first time to my channel, please consider subscribing. So the first question, it is asked in GATE 2008 for chemical engineering branch. In this he has given that a analytic function w of z is defined by u plus iv, and he has given you the real part and you are asked to find the total function. See, always remember, if you are given with u or v, that is imaginary or real part, and you are asked to find the function, you have to use Milne-Thomson method. Milne-Thomson method. So if you are given with u or v, and you are asked to find v or u, that is its complex harmonic conjugate, so you have to use the concept of harmonic conjugate method. Okay, so don't get confused between those two methods. Okay, so whatever may be this, if you are given with u like this, you have to find first ux and uy, that is differentiation of u with respect to x and y. Okay, so I'm finding ux now. So this is of the form u by v rule. So u by v rule, so first of all, differentiating numerator with respect to x, you will get 0. Okay, 0 into x square plus y square, minus differentiating denominator with respect to x, you will get 2x. Okay, so d by dx of x square is 2x, and y is a constant, d by dx of y square is 0. U dash into v, so u dash v minus v dash u by v square. V square is denominator whole square, that is x square plus y square whole square. So you will get minus 2xy divided by x square plus y square whole square. Similarly uy. Okay, so differentiating first with respect to y, that is numerator, so you will get 1 into x square plus y square, this is u dash into v minus v dash is 2y. Okay, so differentiating denominator with respect to y is 2y into u, that is y, divided by x square plus y square whole square. So it will be x square minus y square, so plus 2y square minus 2y square is minus y square, x square plus y square whole square. Okay, so this is ux and this is uy. So we know that w dash of z is equal to ux plus I into vx, but from Cauchy-Riemann equations what we have, vx is equal to minus ui, so it will become ux minus I into ui. This is w dash of z. So w dash of z is equal to ux is this one, right, minus 2xy divided by x square plus y square whole square minus I into x square minus y square divided by x square plus y square whole square. Okay, I've just substituted ux and uy value in this equation. Right, after getting this, what you have to do? Replace x by z and y by 0. Okay, in the place of x you have to substitute with z, and in the place of y you have to substitute 0. So w dash of z is equal to, if you substitute x is equal to z, this becomes minus 2z into, this becomes 0. Okay, so minus 2z into 0, so minus 2z into 0, so this total will become 0. So this total term will become 0, we should not include that. And here this is x square is z square and y square, this is 0, this is z square, so I am writing minus I into z square divided by, so this is z square plus 0, z square plus 0 is z square only whole square. Okay, so 1z square get cancels off, so w dash of z is equal to minus I by z square is left over. Okay, so this can be written as minus I into z power minus 2. So w of z is equal to integral of minus I into z power minus 2 dz. Okay, so what will get? Minus I into z power minus 2 plus 1 divided by minus 2 plus 1. So w of z is equal to minus I into z power minus 1 divided by minus 1. So minus minus gets cancelled. So w of z is equal to I by z plus c. Okay, so w of z is equal to I by z. So option C is correct. Okay, so this is how we can find the function when you are given with u and u or v, that is real part or imaginary part of w of z. Okay, so next we'll see one more problem on this. Okay, so has given which of the following is not a real part of some analytic function. So we know that if f of z is an function of the form u plus iv, and if it is said to be analytic, f of z is said to be analytic if the real part and imaginary part of this f of z satisfies the harmonic equations, that is Laplace equations, del square u is equal to 0 or del square v is equal to 0, that is dou square u by dou x square plus dou square u by dou y square is equal to 0, or dou square v by dou x square plus dou square v by dou y square is equal to 0. Okay, so this concept is very very important. Okay, so if your real part, he is asking about real part, if your real part satisfies this equation is satisfied by your real part of the analytic function, then it can be some real part of some analytic function. If this condition is not satisfied, it cannot be a, so he is asking is not a real part of the some analytic function. So if this condition is not satisfied, then it cannot be a real part of some analytic function. Okay, so we'll solve one by one for the given options and we'll check this condition. If this condition is satisfied, then it can be real part, it can be real part of some analytic function. So if this condition is not satisfied, then it cannot be real part of some analytic function. Okay, let us see. U is equal to x cube minus 3xy square minus 3. So ux is 3x square minus 3y square. Okay, next we have to find uxx. What is uxx? Uxx is dou square u by dou x square, that is dou by dou x of dou u by dou x. So this is what you have found. So this is ux, so dou by dou x of ux is uxx. Okay, so uxx is again differentiating with respect to x, so it will be 6x because dou by dou x of 3y square is 0. Okay, next uy is minus 6xy. Next uyy is differentiating again this with respect to y, so you'll get minus 6. And if you find uxx plus uyy, so it will be 6x minus 6x is equal to 0. So this condition is satisfied, this Laplace condition is satisfied, so it can be real part, it can be real part of some analytic function, but he is asking not a real part. Okay, so it can be real part, so this is not the correct answer. Next we'll solve for b, that is u is equal to cos x cos hy. So ux is d by dx of cos x minus sin x into cos hy, and again uxx, so it will be minus sin x is d by dx of sin x is cos x, negative sign as it is I am writing, so this negative sign as it is I am writing, d by dx of sin x is cos x into cos hy. Next uy is cos x constant and d by dx of cos hy is sin hy, and uyy is, so cos x into d by dx of sin hy is cos hy. And even if you observe, uxx plus uyy is equal to 0. Both gets cancelled off. Okay, so this is minus term and this is plus term, so both will be cancelled off. You'll get still uxx plus uyy is equal to 0. Okay, still this condition is satisfied, so it can be real part. Okay, so this is not the answer. Next, C. U is equal to x square minus y square minus 4. So ux is 2x and uxx is 2. Uy is minus 2y and uyy is minus 2. Even though this also satisfies uxx plus uyy is equal to 0. 2 minus 2, so it will become 0. Okay, this is also satisfying, so this can also be a function of some, this can also be a real part of some analytic function. Fourth one, u is equal to x square plus y square plus 4. Okay, so ux is 2x, uxx is 2, uy is 2y and uyy is 2. So uxx plus uyy is equal to 4. It is not equal to 0. So this condition is not satisfied. This condition is not satisfied by this fourth option. Okay, this is not satisfying the Laplace condition. So this cannot be a real part of some analytic function. Okay, so option D, it cannot be a real part of some analytic function because it is not satisfying the Laplace equation. Okay, so this is how we can find whether the given function is a part of a real part or imaginary part of some analytic function. So it should satisfy these conditions, Laplace conditions. If you are given with u, it should satisfy this condition. If you are given with v, it should satisfy this condition. Okay, so next we'll see one more question on this. Okay, so he has given x cube y minus y cube x is equal to constant is a family of curves, then find its orthogonal trajectory family of curves. Okay, so this is same as the concept of harmonic conjugate only. Okay, harmonic conjugate concept only, right? So here the wording is different. He has asked to find orthogonal trajectory. So even if you are asked to find harmonic conjugate, or if you are asked to finding orthogonal trajectory family of curves, both are same. That is, f of z is equal to u plus iv is some analytic function, then u and v are orthogonal trajectories of each other. Orthogonal trajectories of each other. That means if you are given with u, if you find v, that becomes its corresponding orthogonal trajectory. If you are given with v and if we find u, then it becomes your orthogonal trajectory of the given function v. Okay, so this concept is again found by using the concept of harmonic conjugate concept only. Okay, so only wording is different. Orthogonal trajectory means again you have to find v if you are given with u. Okay, so I'm assuming that the given function is u x cube y minus y cube x. I'm assuming it as u and I'm finding ux now. So ux is 3x square y minus y cube. Next uy is x cube minus 3y square x. Okay, right. So next is dv is equal to, so you have to find v, so it is vx dx plus vy dy. So first of all you have to take like this from the concept of harmonic conjugate only. So from Cauchy-Riemann equations, ux is equal to vy and vx is equal to minus uy. So vx can be substituted with minus uy dx plus vy can be substituted with ux dy because you are given with only u function, right? Minus uy we need, so minus uy is 3y square x minus x cube, reverse, you will get reverse. Okay, 3y square x minus x cube dx plus ux is this one, 3x square y minus y cube dy. This is dv. Okay, so what is v? V is equal to, I'll write directly, 3y square x minus x cube, because this concept I have already explained you in one of the video, okay, with examples. So dx, right, treating y as constant, plus terms independent of x. Terms independent of x is, if you observe this first term, it is having the function x, so okay, it is having the variable x, so it is not independent of x. But if you see the second term, it does not contain any x, so it is independent of x, so it will be minus also you have to take, so minus y cube dy is equal to, sorry, plus c. So v is equal to, so 3y square, y is also constant, so 3y square is totally constant, integral of x dx minus integral of x cube dx minus integral of y cube dy plus c you will get. Okay, at last you can add c, okay, no problem. So 3 into y square into x square by 2. Okay, 3 into x square by 2 minus x to the power of 4 by 4 minus y to the power of 4 by 4 plus c. Okay, so this is the function v. V is equal to 3x square y square by 2 minus x to the power of 4 by 4 minus y to the power of 4 by 4 plus c. Okay, so the important point here is, if you are given to find the orthogonal trajectory family of curves, then also you have to use the concept of complex conjugate. Okay.